Good morning students, this is Dr. Shekhar from Department of Science and Humanities. So today we are going to take up another session of electrochemistry. So in this session I am going to take a new topic called as electrochemical series. So in this video lecture I am going to talk about what is this electrochemical series all about, and at the end of the day we are going to understand the significance of the electrochemical series. So let us start the final topic, that is electrochemical series. As we told previously that whenever we are having a potential difference set up between the metal and its ions, we call it as electrode potential, and each metallic strip is going to have its own electrode potential. So the electrode potential varies from one metallic strip to another metallic strip, or I can say that from one metal to another metal, or from one element to another element. So whenever we are having this arrangement of electrode potential in the increasing order of their values, then we call it as electrochemical series. So electrochemical series is also called as the activity series, where all the elements are arranged in the increasing order of standard reduction potential. So you can see here we are having the element lithium on the top of the electrochemical series, and fluorine being the element which is occupying the last place in the electrochemical series. And why is it so? Because lithium is more electropositive element, and fluorine being the most electronegative element. So in this series we are having all the electropositive elements on the top of the electrochemical series, and we got actually the electronegative elements at the bottom of the electrochemical series. And all these elements which are on the top, they are good reducing agent. What is meant by reducing agent? They have the tendency to reduce other elements and itself undergoes oxidation. Let me start with the lithium. So lithium has got atomic number 3. So it has got one electron in the outermost shell. So lithium has more tendency to lose that one electron to become Li plus, releasing one electron. So since this lithium has got more tendency to undergo actually oxidation, so this actually element is on the top of the electrochemical series. So it is a good reducing agent. And we have got the other case, fluorine. Fluorine requires only one electron actually to become octet. Now this one electron is required by fluorine to form F minus. So we can see here the electropositive elements are on the top of the electrochemical series, and the electronegative elements are at the bottom of the electrochemical series. So the elements which are at the bottom, they are good oxidizing agents. That means they oxidize others and itself undergoes reduction. And these elements are less active. That means they don't participate in giving electrons. And we have got actually elements on the top of the electrochemical series which are more active. That means these elements, they have got more tendency to lose electron. So since these elements have got more tendency to lose electrons, they are best reducing agents. And we have got elements at the bottom of the electrochemical series which are strong oxidizing agent, and these oxidizing agents, they have got more tendency to accept electrons. So you can see in this electrochemical series, hydrogen has been given the value of 0. That means the elements which are above hydrogen, they are more electropositive in nature, and the elements which are below hydrogen, they are most electronegative in nature. And we should know that all these values have been calculated at a standard temperature of 25 degrees centigrade and 1 atmosphere pressure. So while calculating the half cell values of all these metals or elements, they have been calculated at the standard temperature and pressure. So, you can see here, when we go from the top to the bottom, so the tendency to undergo reduction will increase. And how is that? Actually it is what you call can be observed. We start from the most negative value and we reach to the 0, and again we start actually increasing to the positive values. So minus value means they have got less tendency to undergo reduction, positive values means they have got more tendency to undergo reduction. So those elements which are placed above hydrogen, they have got less tendency to undergo reduction. Less tendency to undergo reduction means minus value, and plus value means more tendency to undergo reduction. So you can see here we have got lithium followed by the potassium. So all the electropositive elements, then followed by the group 2 family, okay, the barium, the calcium, then again coming the aluminium, zinc, iron. All these actually elements are electropositive elements because they have got more tendency to lose electrons. And we can see here as we go down the group, okay, below hydrogen. So since actually the last element is fluorine, so the elements actually which are above fluorine, actually they are also electronegative in nature, but fluorine is the most electronegative element. We should know that why this electrochemical series is very important for any of the engineering graduate students. Let us try to understand. So this electrochemical series help us to calculate the EMF or the electromotive force of any of the galvanic cell. Secondly, it also tells about the tendency of oxidation or reduction. So this actually series will tell which element has got more tendency to undergo oxidation and which element has more tendency to undergo reduction. And it also tells about the displacement reaction of one metal over another metal. And we can also predict the spontaneity of a chemical reaction, okay. We just have to know that whether the reaction is spontaneous or not. So for that reason we have to depend on the electrochemical series. And finally, it is also helpful to calculate the equilibrium constant of any of the reaction. So let us go one by one to understand the significance of this electrochemical series. Coming to the first part. So since we know that in electrochemical series we have got all the elements in the increasing order of their standard reduction potential values. So let us try to understand how to know the EMF of any of the galvanic cell. Since we know that the basic galvanic cell, that is zinc dipped in zinc sulfate and copper dipped in copper sulfate solution connected by a salt bridge. So since we know that zinc has got a value of minus 0.76 and copper has got a value of plus 0.34, okay. So this actually cell potential value refers to zinc with relative to zinc sulfate, and this cell potential value reflects the value of copper with the copper sulfate solution. And we also know from the intermediate that the EMF of a cell can be written as E cathode minus E anode. That means cell potential value at the cathode minus cell potential value or the half cell potential value at the anode. So applying actually this value to this formula, we can easily make out the cell potential of any of the reaction. So for copper, since actually in a galvanic cell zinc is losing electrons and copper is accepting electrons, so reduction always occurs at the cathode. So copper actually is the half cell where reduction process occurs. So we are substituting the value as 0.34 minus of and 0.76. So this value comes to plus 1.1 volts. So for a typical galvanic cell, the value is EMF is 1.1 volts. So in this way we can find out the value for any of the electrode. So let us try to understand the galvanic cell between magnesium and copper. So we know that the value for magnesium is minus 2.37. The value for copper is plus 0.34. If at all I would like to calculate the EMF for a galvanic cell made of magnesium and copper electrode, then it is easy for me to find out the EMF of a reaction. So again substituting E cathode minus E anode, we can easily find out that the value will be so this is the way we can say that the value is approximately 2.7. So likewise we can find out the EMF of any of the galvanic cell or any of the electrochemical cell. Let us go to the next one. This electrochemical series help us to calculate whether which element has got more tendency to undergo oxidation and which metal has got more tendency to undergo reduction. Let us take two elements, lithium and Pb, that is lead. From the electrochemical series we can make easily that lithium has got a minus value minus 3.03 and lead has got also minus 0.13. But while trying to understand both the elements are electropositive, which is more electropositive, we should easily make sure that the element which has got more negative value is more electropositive in nature. The element which has got less negative value is less electropositive in nature. So if at all I say that among lithium and Pb, lithium has got more tendency to lose electrons in comparison to Pb. Though both lithium and lead are having tendency to lose electrons, from the electrochemical series value we can make very sure that lithium is more electropositive than Pb. So higher oxidation potential means higher tendency to undergo oxidation. Here we should make sure that all the elements are arranged in the increasing order of their standard reduction potential. So if it is having more actually oxidation potential value, it will have less reduction potential value. The oxidation potential value for lithium will be plus 3.03 because oxidation potential value is inverse to the reduction potential value. So I can make sure that lithium is having higher oxidation potential value, that means lower reduction potential value. So it is very much electropositive when compared to lead, which has got less oxidation potential value. So in this manner we can say that elements can be easily figured out based on their reduction potential values or oxidation potential values. Let us go to the next one. Consider two elements below hydrogen and let us take the example of silver, that is Ag, and gold, that is Au. In order to find out which element or which metal has more tendency to undergo reduction, the values speak out themselves. Here silver has got the value of plus 0.8 and gold has got the value of plus 1.52. Since gold is having more tendency to undergo reduction, so it will have more positive value. Silver has got less tendency to accept electrons, so it has got less reduction potential values. Both have got the tendency to accept electrons, and that is the reason both have got plus sign. But we should know that among silver and gold, it is gold which has got a higher tendency to accept electrons. So gold is a strong oxidizing agent, that means it oxidizes others and itself undergoes reduction in comparison to silver. So in this way this electrochemical series will tell out which metal is prone to undergo corrosion in comparison to other metal. The elements which are on the top of the electrochemical series above hydrogen, they are acting as a anode. That means they have got more tendency to undergo corrosion or more tendency to undergo loss of electrons, and the elements which are below hydrogen, they act as cathode. That means these elements, they accept electrons, and we should know that accept of electrons occurs only at the cathodic region. So the elements which are above hydrogen, they act as anode, and the elements which are below hydrogen, they act as cathode. So this is the way this electrochemical series will help us to find out based on the reduction potential values. So the elements which are having negative reduction potential values, they can act as anode, and the elements which are having positive reduction potential values, they can act as a better cathodes. And this electrochemical series will also tell us whether we can carry out a displacement reaction between a metal and its solution. Let us try to take a simple example. We have got a zinc rod, okay, and this zinc rod is placed in the copper sulfate solution. What is meant by displacement reaction? We should know that in a displacement reaction, zinc will displace copper out. So if at all I write the reaction Zn plus CuSO4, I can make sure that ZnSO4 will form precipitating copper. So zinc is displacing copper from its solution. So we should know that whenever the zinc is converted to zinc sulfate, the oxidation of zinc is changing from 0 to 2. And copper is changing its oxidation state from 2 to 0. So zinc is undergoing oxidation and copper is undergoing reduction. So from the electrochemical series, we can be very sure that since zinc is having higher potential value, that means has got higher tendency to undergo oxidation with a negative value, and copper has got more tendency to undergo reduction with a positive value. So I can make sure that this displacement reaction will work out very easily because the values speak out themselves. So more negative value means they can displace the elements below them in the electrochemical series. So the elements which are on the top, they can displace very easily the elements which are at the bottom of the electrochemical series. In this way, I can make sure that the zinc rod is definitely going to displace out copper from its solution. So because the zinc has got minus 0.76 value and copper has got plus 0.34 value. So this displacement reaction can be easily made out by calculating the EMF. That means the cell potential, which comes to 1.1 volts. So since the EMF value is positive, so we can be easily sure that the reaction is a spontaneous reaction. Similarly, the elements like magnesium, aluminium, iron can also displace copper from its solution. So all the elements which are on the top above hydrogen, they can displace the elements which are below hydrogen in the electrochemical series. So the displacement reaction of one element by another element can be easily worked out using a electrochemical series. So the elements which are having the negative values, they will displace the elements which are having the positive values. We can also actually work out the displacement of hydrogen gas. The only difference between metals and non-metals is that metals can displace hydrogen gas, whereas non-metals cannot displace hydrogen gas from mineral acids. What are these mineral acids? HCl, H2SO4, HNO3. Okay. So all these are mineral acids, and these mineral acids are just like salts, except that they are having a hydrogen instead of any of the metal ion. Okay. So we can be very sure that metals will displace hydrogen actually from mineral acids. So whenever I write this reaction Zn plus HCl, I can be very sure that it is going to form ZnCl2, liberating hydrogen gas. So this reaction tells very clearly that the elements which are above hydrogen, they can easily displace hydrogen, and zinc, aluminium, magnesium, sodium, and these are the elements which are placed above hydrogen. They can easily liberate hydrogen gas from mineral acids. Let us try to understand. Zinc is placed just above hydrogen. So it just actually liberates hydrogen gas, and we can see the evolution of bubbles. Let us take another element. We have got sodium, which is placed much higher than zinc in the electrochemical series. Since actually the difference between hydrogen and sodium is more, we can see that the sodium actually will react vigorously, and it will liberate hydrogen gas very fast. Parallelly, we have got potassium, which is placed much higher actually in the electrochemical series, and this actually potassium will violently react hydrogen gas, and the reaction is so exothermic that it will catch fire. So from this actually we can easily make out that the tendency of potassium to liberate hydrogen is more efficient when compared to sodium, and this efficiency of sodium to liberate hydrogen gas is more in comparison to zinc. So all these elements, they liberate hydrogen gas. Using this electrochemical series, we can also predict the spontaneity or the feasibility of the reaction. We have taken actually in the beginning of the lecture that most of the electrochemical reactions actually are spontaneous reaction, where the chemical energy is converted into electrical energy. To understand whether the reaction is spontaneous or not, we have to actually work out with this equation, where the free energy is equal to minus NF E naught cell, where E naught cell actually is the reduction potential at a standard condition, and Fa is the Faraday constant, which is 96500, and N is the number of electrons actually transferred actually during the reaction. So let us try to understand the simple galvanic cell, where we have got zinc and copper as the electrodes. So we know that zinc has got a value of minus 0.76, and copper has got a value of plus 0.34. So if we calculate the cell potential, the value will be plus 1.1. Since it is having plus E naught cell value, so when we substitute actually this value to the free energy, then definitely we are getting a negative value. So more negative value means more spontaneous reaction. So this electrochemical series can easily predict any of the reaction. So whether the reaction is spontaneous or not, whether the reaction is a forward reaction or a reversible reaction. So we should know that whenever we are having the cell potential or the EMF with a positive sign, delta G becomes negative, and which is a spontaneous reaction. If the EMF of the reaction is negative, that means the reaction actually will be positive for delta G. So obviously the reaction is a non-spontaneous reaction. So whenever we are having E cell value positive, delta G will be negative. So, it is a spontaneous reaction, and whenever we are having E cell value negative, the delta G value will be positive for a non-spontaneous reaction. And using this electrochemical series, we can also calculate the equilibrium constant for any of the reaction. We know from the intermediate that the relation between E cell and equilibrium constant can be given by E cell is equal to RT by NF natural log K, where K is the equilibrium constant. So, whenever we are having the EMF more than 0, that means the reaction equilibrium constant will be more than 1. So, the reaction moves in the forward direction. Similarly, whenever we are having the cell potential value less than 0, that means negative value, then K will be less than 1, and the reaction, actually the reverse reaction will dominate in this situation. So, we can just understand actually the spontaneity of the reaction and as well as the direction of the reaction using a simple triangle where the delta G value, the equilibrium constant and cell potential are occupying the three corners of a triangle. So, whenever we are having the cell potential value more than 0, that means positive value, that means delta G will be negative, because delta G is minus of NF E naught cell. So, since we are getting positive E cell value, that means delta G value should be negative. In those cases, actually the reaction is spontaneous with equilibrium constant more than 1. And whenever we are having E cell value less than 0, that means if the E cell value is negative, then delta G will be positive. In those cases, the equilibrium constant will be less than 1, the reaction will be in the reverse direction. And whenever we are having equilibrium constant 1, that means the rate of the forward reaction is equal to the rate of the backward reaction. In those cases, the system is at equilibrium and there is no net reaction. I hope that this actually electrochemical series actually was very useful to understand some of the factors such as EMF, the spontaneity of the reaction, the liberation of hydrogen gas, the displacement of one metal by another element, as well as calculation of the equilibrium constant. Okay, madam.